Here is a P series. The P is 1.001, that is slightly greater than 1. So since P is greater than 1, we say that this P series converges. What I want you to do is I want to use the integral test to show the same conclusion. First of all, you identify the function. The function is f of x equals to 1 over x to the 1.001 power. Okay, and then you need to show three things. You need to show that for x greater than or equal to 1, the function is positive. How do you know that the function is positive? Because the base is positive, greater than or equal to 1. The base is positive. Positive raised to a power is positive. 1 divided by that positive denominator is positive. And then the function is also continuous, because for x greater than or equal to 1, there is no vertical asymptote. None of the x value will make the function undefined. And then this function, I can put that as x to the negative 1.001, negative exponent, and then to show decreasing, I will take the derivative of that. You bring the power down, and then x to the that power minus 1, and then this is equals to this coefficient divided by x raised to the positive exponent. Okay, and then for x greater than or equal to 1, do you see that the top is always negative and then the bottom is positive? Negative divided by positive, that shows that the slope is negative. That means the function is decreasing. And then for the integral test, positive check, continuous check, decreasing check, then we are ready to use the integral test. The integral test is from 1 to infinity, you have 1 over x to the power dx, and then that is equals to limit as b approaches to infinity. You need to set up this improper integral, and then writing the limit is required. 1 to b, and then x to the negative 1.001 dx. Okay, then let's integrate. So you need to take that, add 1 to it, x to the negative 0.001, and then 1 divided by that exponent. Okay, the integration is finished, and then such that x goes from 1 to b. And then you have, that number is, you know what, this one, how about this? I will just hold on to this step, and then I will write another step that is equals to 1 over, that little fraction is negative 1 over 1,000, x to this power. And then that is equals to negative 1,000, x to the this negative exponent, and then such that x goes from 1 to b. And then we are ready to plug in. Okay, when you plug in an infinity, what do we have? Okay, how about this? This one, I can even do this. I will just do negative 1,000 and then divided by x to the 0.001. So let's make that look like 1,000. Okay, when you plug in an infinity, you have this negative 1,000 divided by, you have infinity raised to 0.001 minus negative 1,000 over 1 to the power. Okay, what do we have? This one is going to be give you a plus 1,000, a plus 1,000. Okay, let's move this up, and then we have a plus 1,000. And then what about here? What about this? Okay, this one I did some math using my calculator. So let me count how many zeros I use. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I used 11. Let me double count. 4, 8, 9, 10, 11. All right. I use this. I use 1 followed by 11 0. You don't have to follow me using exactly 11 zeros. You can try to use any numbers of 0, as long as that number is really large, this is approximately equals to 1.03, and then you have negative 1000 divided by 1.03, that is around negative 975. So this will definitely not make an infinity. This will not make an infinity. So that is approximately negative 975. And then, oh, okay, this one I just use an approximation, all right? So you add 1000, that is equals to 25. So that means we have a finite sum. We have a finite sum. So what finite sum? We start from the series. Okay, so I'm going to copy and then paste that right here. And then we say this series is equals to this integral. Copy and then paste right here. So we say the series is equals to this integral, and then this is equals to finite sum. I won't report the 25 because this one I just gave myself a number. So as long as I know that that is defined and that is not equals to infinity or undefined, then that will be a finite sum. So since that is equals to a finite sum, we say the series converges. So that one is converges by the integral test. And then at the beginning, we say converge, that is using the properties of a p-series. All right, so that is the end of this problem. And then I will just put one problem in each video to not make the video too long. All right, I will see you all in the next video.